right, folks, I'll call our circus to order. I'll babble about unimportant things for a second while people get their evening meal and filter in, find a seat. First of all, I am not wired for projection. I'm wired for recording on advice of my attorney. No, just kidding. Really, just kidding. So I'm just going to have to talk loud. I don't have a mic to project to you. And I have never once heard anyone complain about my voice not being loud enough. Second of all, I thought I should explain the genesis of this event. It actually has, what? Wow, you guys are on a hair trigger. It has nothing to do with that ancient text I just humorously referred to. In fact, I'm teaching the upper division genetics course right now. Evolution is a major theme of that course, and some of the students came to the course through a different path and haven't taken our biology sort of evolution course taught by the real experts on the subject. And so I said, well, I guess we should have a night where we get together and talk about the evidence. They said, that sounds great, and someone leaked it to the press, and next thing you know, there's a room full of people. So we opened it up to the community because it's a topic apparently people are interested in. But just so you know, I didn't think it would be fun to have a talk about evolution just because we happen to be in the middle of a sort of tense time on that subject. They actually are unrelated. Let me introduce myself. I'm Steve Matheson. I am a professor in the biology department. My particular area of interest and expertise tends to be developmental biology and the brain. I'm into the brain. So I am not by trade an evolutionary biologist. I'm a developmental biologist. You might know that those two fields overlap quite a bit, and I will shamelessly cherry pick data that's according to the stuff I think is interesting from developmental biology. But in any case, that's what I'm into. I do defend evolution. It's kind of one of my hobbies. And tonight I'm trying to make a really simple point about how to think about evolution. I'm going to start by asking you to think about the concept of explanation with me. And I'm going to take you to a place near where I grew up, not that near, but I grew up in Phoenix, Arizona. And in the northern part of Arizona, near a city called Flagstaff, there is, up in that high plain there between Flagstaff, Winslow, and the Grand Canyon, sort of, they're all up there. It's a really high plain. There is a gigantic hole in the ground. So let me describe it to you because it's actually very interesting. It's about a mile across, this hole in the ground. It's at its deepest, something like 570 feet deep. So it's humongous. It's a bigger hole in the ground than any of you have probably ever seen. It has a rim around, so it's roughly circular. It has a rim around it that rises about 150 feet above the surrounding sort of desert sand. Can anyone picture what I'm describing? Maybe some of you have been there. Now, when I was growing up in Arizona, and it was on private property, and I couldn't go see it. In fact, it still is apparently on private property, but now it has a visitor center and a theater where you can watch movies about how it came to be. Here is a picture of it. And its official name now is Barringer Meteorite Crater. When I was a kid, we just called it Meteor Crater. Of course, that's inaccurate because meteors are in the sky, but this is on the ground. Yeah. Barringer Meteorite Crater, and you can go there to visit it and check it out. And it really is a mile across. Now, I'm a scientist. Many of you in the room are scientists, and I think that thing sort of cries out for explanation. So what is it that caused this? The name is cheating, by the way, right? Well, it's obviously a meteorite. Now, wait. About 100 years ago, there was some interesting scientific controversy about the formation of this feature on the Earth's surface. And I think you can probably guess what the two competing theories were. One of them was that some big rock fell out of the sky and hit the Earth really hard. All right, we'll call that the meteorite theory. Does anyone want to take a wild guess what the competing theory was? Volcanoes. So some kind of volcanic or other geophysical phenomenon. All right, so there was apparently a debate. And the way the debate was settled was not when the person who bought it decided to name it Meteorite Crater. Instead, somehow, scientists came to a consensus that this was caused by a big piece of extraterrestrial rock hitting the planet. Let me give you some hints about how they came to this conclusion. Well, first of all, as far as I know, they did not use time travel, and none of them was old enough to have observed the impact. Therefore, they were discussing an event that occurred in the past. They had no eyewitness accounts, not even from the really old trees in the area. No way to know what really happened. Relatively little in the way of precedent for this kind of event in their lives, I'm guessing, so they couldn't say, well, it happened in my backyard last week. So, how do you think they came to this consensus? First of all, don't you think it would be silly for us now to say, well, I mean, it happened in the past, you can't really prove it, they should rename it, they should call it Barringer Meteorite or Volcano Crater. You know, to give equal time to the two competing theories. Well, they didn't do that. How do you think they came about this? I think it's pretty clear what they did. They asked which of these two competing theories best explains what we see at this site. They did not say, how does the data force one conclusion or another? It's a very subtle distinction, but it's really important to us tonight. They're not asking, can you prove it was a meteorite? Because the answer to that question is no, unless you got some squishy definition of the word prove. No, I wasn't there, if that's what you mean. What I'm saying is, all the observations we've made, the shape, the size, the other rocks in the area, there's some meteorite-like rocks in the area, various other features of it led scientists to finally conclude this was a meteorite impact. We're quite sure of it. The meteorite theory explains the data better. Now, a couple of points that are important to us tonight. The folks that named this thing meteorite crater were clearly extrapolating their current knowledge into the past. They weren't there. Maybe the rules were different back then. Nobody talks like that. Maybe back then trees fell and made meteorite craters. No, we don't think so. We know how things work today. We went ahead and extrapolated into the past. Going out on a limb, maybe, but most of us don't think so. They extrapolated what they know into the past. How far back? 50,000 years. Might sound like a lot to you. It's kind of a teeny tiny little amount of time in geologic terms, but they extrapolated their knowledge into the past. Let me also point out that anything like this will clearly allow multiple possible explanations at the same time. So, I'm guessing there's a lot of Christians in the crowd. Now, if I looked at this thing and said, oh, it's beautiful, and I do happen to think it's pretty cool, I said, God made that. And then we took a poll. I don't know how many of you would disagree with me. No, he didn't. And my simple point here is, my explanation that a big piece of rock hit the earth at a really high speed is fully compatible with another explanation or another answer to a question, which is God made it, or God put it there, or anything else like that. So if I ask you a question, how did your nose come about, and you say God made it, I'm not going to say, nope, that's wrong. But I might say to you, yeah, that's not quite what I meant by my question. All right, so if you, by the way, people who hate meteor craters, they think they're evil, maybe you don't think God made it. Can we save that for later? My point is, it's perfectly legal when I'm using the squishy word explanation to say, well, your explanation, scientist, about rocks falling from the sky, your completely natural explanation, sounds kind of atheistic to me actually, your explanation clearly rules out my explanation, which is God. I think we would all laugh and say, oh, no, it doesn't. And we can get more specific about that if we want later. But one more thing. Can you think of other explanations? Kind of let your imagination go for a second. And maybe I can help you. The old people in the crowd, I won't define that term, once saw a movie, I know I did, called Starman, starring Jeff Bridges. Does anyone remember it? Put up your hand if you saw Starman. Oh, there's a few old people in the crowd. All right, and some film buffs who aren't old, but they saw it, they kind of pulled it out of the archives. Starman, do you remember the final scene of Starman? No, because none of you saw it. It's about an extraterrestrial comes and love affair, same lame storyline as in every extraterrestrial love affair movie. But anyway, he comes, and at the end, his buddies come to pick him up. And do you know where they picked him up? There. Clearly, they were suggesting that this crater was formed by an enormous spacecraft and used it as a landing and taking off area and eventually pushed the rocks to the side from the jets coming out of the bottom of the spacecraft. I don't know. So, is that an explanation for this hole in the ground? The correct answer is yes, it is. I don't think it's right. But I can design in my head a spacecraft that it can account for all of these observations, including meteorite-like rocks, because the extraterrestrials brought them and they were ballast and they threw them out when they were done, or something like that. Now, maybe you don't like this idea of a scientist getting all sort of weird and crazy, but the fact is there are an infinite number of explanations for this hole in the ground. We chose one. And I think you all agree with me this was a meteorite impact, and you're not willing to argue with the scientists on this score. We chose one based on some kind of gut-level feeling that it's better. Not, that's it, you proved it to me, F equals ma. We thought differently about this crater. We just said that's the best explanation. And if I forced you, if I really pushed you to tell me why it's the best explanation, eventually you would give up and say, I don't know, it just is. There's some kind of value system we have to judge what's a good explanation. There are things like Occam's razor and adding extra crap, and there's all sorts of rules about this. Come on. The point is not that the meteorite it meets some set of specific criteria. It's that we judge it to be a better explanation than the extraterrestrial explanation, perhaps because you guys have never seen extraterrestrials. I don't know why, because I'm betting most of you haven't seen giant meteorites either. In any case, here's what I want to say to you tonight. I want you, if nothing else, to think about evolution when you leave here, not as something that you would argue about whether it's proven or not, but whether you would be willing to consider that that theory explains data really well. The meteorite theory explains the data. I'm trying to tackle it from the other direction. Not the data indicates a meteorite. You know, that's probably also true. And I think the data for evolution and common descent specifically, which is our topic tonight, is overwhelming. I do. But I'm trying to get you to think a little bit differently. Not say, the evidence is so compelling, eventually I just gave up and accepted it. Instead to say, you know what, I see how that theory explains all those data. I get that. That's our goal tonight, okay? Are we clear about that? We won't go back to meteors again, or even extraterrestrials, I don't think. Okay, our topic tonight is specifically common ancestry. And the first thing we should talk about is this idea of the tree of life. This is what we're talking about tonight. We are not, and this is on your outline, specifically going to go into natural selection, random mutation, genetic drift, all that interesting stuff, the so-called engines that drive this thing. Great stuff. I assume you need to be home at some point and go to sleep, so we're not going to talk about that. We can schedule that for another circus. Tonight we're just going to talk about the tree of life. We're going to talk about common ancestry. Here's one picture of the tree of life. Does anyone know where that comes from? Professor Ratch.
That's the only illustration in the origin.
This is the only illustration in a book you might have heard of, written by a naturalist named Darwin. What? Someone brought it. Oh, did I just blind you? Smart Alec in the front row brought his own copy. Either that or he stole mine, because I have the same Barnes & Noble version of that classic. Professor Darwin wrote a book in 1859, went through 6 editions and so forth. This is the only picture. This is not so much the tree of life. That's not at all what this picture is of. But it gets at what we're talking about, which is that organisms, or more to the point in our case, populations and species, have sort of branching tree-like histories. They started